Okay, today we're doing 6.2.1. So I'd probably open your book to that page. If not, I'm going to have the book up on here so you guys can look at it. We're doing multiplication and dilation. I do want to point one thing out though. Dilation is usually what you guys think about, like when you go to the eye doctor, they dilate your eyes, which means your pupils get bigger. Dilation can also mean smaller. So this can be bigger or smaller. I just want to point that out because that's one misconception that people have with dilation. Dilation doesn't have to mean it gets bigger. It can also mean it gets smaller. So can you guys in your notebook go ahead and label your page 6.2.1 multiplication and dilation. Okay, this says, remember that when an object is translated, rotated, or reflected, it stays the same size and shape even though it moves. For this reason, these types of movements are called rigid transformations. In this lesson, you will explore a new transformation that changes how the object looks. As you work today, ask these questions. You don't really have your team, sorry. So just ask these to yourself. They're good questions to think about. It says, what parts of the shape are changing and what parts stay the same? Okay, the first problem we're doing says when all of the x or y coordinates of each vertex of a shape are changed by adding or subtracting the same numbers, this shape translates to a new position on the coordinate graph. You learned in lesson 6.1.3 that when one of the coordinates of the vertices, which is the points on your shape, is multiplied by -1, the shape is reflected over the y-axis or the x-axis respectively. So remember when we wrote down, if you multiply the x by a negative, it flips over the y. If you multiply the y by a negative, it flips over the x. That's what they're talking about. So it says, how do you think the shape will change when both the x and y coordinates are multiplied by the same number? Use the directions below to help you answer the question. Plot the points on graph paper. I'm going to add my graph paper in here so I can do this with you guys. Okay, before we do this, how do you think the shape will change if you multiply by the same number on the x and the y? I want you to make that prediction in your notebook, so just write a prediction about what you think will happen if you multiply the x and y coordinates by the same number. So go ahead and make that prediction, pause this to make your prediction, and then we'll do the next part. Okay, now we're going to plot these 4 points on graph paper. This is part A. So we have the point 2, 1. I need to change colors so you guys can actually see this. 2, 1, 3, 1, 5, 5, and 2, 5. If at any time you guys feel like I'm just leaving you in the dust, go ahead and just pause. I just don't want to make this a crazy long video, so if you need a pause, pause. Okay, so you should get this quadrilateral. It says, without graphing, predict how you think the figure will change if the x and y coordinates were multiplied by 2 and then plotted. So we're going to multiply all of these by 2. 2 times 2 is 4, 1 times 2 is 2, 3 times 2 is 6, 1 times 2 is 2, 5 times 2 is 10, 5 times 2 is 10, 2 times 2 is 4, 2 times 5 is 10. So these are the new plots we're going to plot now. So I'd pause this and then go ahead and plot those. Okay, so these are the points that you should have, and you can see from this that it made it bigger and it also moved it to a different location. So what it did, because we multiplied by 2, it made that image twice as bigger. It also moved it twice as far away from the origin. So you can see that if you did rise over run, you'd have 1, up 1 over 2, up 1 over 2. So it's twice as far away as it was before. Okay? This is actually called a dilation. In your guys' notebooks, I want you to make an umbrella because dilations are one of our transformations. This is the final one. We've learned 3. This is the last one. So make your umbrella. The big umbrella is transformations. Mine obviously did not fit on there, but it's transformations. And we have 4 transformations. The first one is reflection. And reflections flip whatever you have. The next one is rotation. And rotations turn it. Then we have our new one, which is dilation. And dilations make bigger or smaller. And the last one is translation. And it was actually the first one we learned. And translations move it. So the reason I'm having you make this umbrella is because translation and transformation sound really, really similar. However, they're not the same thing. If YTOP or any kind of test or any worksheet or anything like that asks you if a transformation has taken place, that means the image could have been reflected, rotated, dilated, or translated. Any of those things could have happened if they ask you if a transformation has taken place. So this is a transformation, it's all of them. If they ask you if a translation has taken place, a translation is only moving it. So if it's bigger, if it's turned, or if it's flipped, it is not a translation. So that's what this umbrella is for. Okay, the next part says, the students in Miss Stanley's class were studying what happens to the graph of a shape when both coordinates are multiplied by the same number. They came up with these questions. What happens when each coordinate is multiplied by 1/2? What changes when the coordinates are multiplied by 1? What happens when both of the coordinates are multiplied by -1? And what happens when the coordinates are multiplied by -2? I want you to go ahead and pause this video, and when you pause this, I want you to make a prediction in your notebook, so probably 1 sentence at least, for each of those 4 things before we do it. So go ahead and pause and make your prediction. Okay, now we're actually going to test these predictions and see what is going to happen. So I want you to plot a couple points. Let's do 2, 4. Ooh, that was really big. Okay, 2, 4. Let's do, and I'm going to label this as 2, 4 so that you guys can look back at it. Let's do 5, 4. Ooh, let's not do 5, 4 actually. That's not going to work out very well. Let's do 4, 4. And we'll label it as 4, 4. And let's do 4, 6. Okay, go ahead and pause and get that graphed if you don't already have it graphed. Okay, the first one says, what happens when each coordinate is multiplied by 1/2? Multiplying by 1/2 is the same thing as dividing by 2. So if we multiply by 1/2 or divide by 2, this one's going to be 1. Ooh, that's a bad color to use. This one's going to be 1, 2. This one's going to be 2, 3. We're just dividing by 2. This one's going to be 2, 2. When you're finished, go ahead and graph those points. I would pause right here and get those graphed. Okay, so you can see our triangle got really, really tiny. So when we multiply by a number between 0 and less than 1, so greater than 0 but less than 1, what's going to happen is you're going to get a smaller figure and it's going to move a lot closer to the center. Okay? So our next one says what changes when the coordinates are multiplied by 1. If I multiply these all by 1, you guys, you're just going to get the exact same coordinates, so you don't really have to graph that one. The next one says what happens when both of the coordinates are multiplied by -1. So that means this is going to be -4, -6. I just took the wrong coordinates for that one. This one's going to be -4, -4. And this one's going to be -2, -4. So go ahead and pause and graph those. So you can see that this is the same as the original one, it's just rotated. So multiplying each of the coordinates by -1 is the same thing as rotating 180 degrees. Okay, let's do the next one now. I'm going to do a little bit of erasing so this doesn't stay super cluttered up here. Ooh, I might not be able to erase that. Nope. This was 4, 6, 4, 4. And this is 2, 4. Okay, so now it says for the last one, what happens when the coordinates are multiplied by -2? So this is going to become -8, -12. -8, -8. -4, -8. Okay, go ahead and graph those. Pause if you need to. Okay, there's my last graph. So you can see it rotated it 180 degrees again. It doesn't matter if it's clockwise or counterclockwise because 180 degrees is the same either way. But then it also made it 2 times as big. So just like when we multiplied by 2 on the last one, it's 2 times as big, 2 times as far from the origin, which is where the x and y axis cross, if you don't remember that. So this dot in the center. So it's 2 times as far away from that, it's 2 times as big, and it's rotated 180 degrees. Okay, the last thing that I want you guys to do is problem 44. So go ahead, read through the whole thing. It's going to have you test something that you want to test. And then it's going to have you tell what happened afterwards. So pause this, read problem 44, and do it, and then restart your video, and we'll talk about the learning log. Okay, the learning log says, in your learning log, explain how multiplying the coordinates of a shape affects the shape. How does the size of the shape change or not change? How do the angles of the shape change or not change? Do these results depend on the multiplier that is chosen? Be as specific as you can and include examples to demonstrate your thinking. Title the entry Dilations. So I'm going to kind of go through this with you guys. So title it Dilations. It says, explain how multiplying the coordinates of a shape affects the shape. So if we multiply by a number that's greater than 0 but less than 1, it's going to make it smaller. It also made it closer to the middle or the origin. I'm just using middle because origin's kind of tough for you guys sometimes still. If your number is greater than or equal to 1, well, not really equal to, but greater than 1, it's going to make it bigger and move away from the center. If your x or your number is multiplied by 1, stays exactly the same. How does the size or the shape change? The shape does not change. Do the angles change? Angles do not change. Do these results depend on the multiplier that is chosen? So we talked about it. This is our multiplier. So if we multiply by something between 0 and 1, it's going to get smaller. Greater than 1, I actually wrote this down wrong, you guys. If x is greater than 1, sorry. If x is greater than 1, it's going to get bigger. If x equals 1, it's going to stay the same. Now I want you guys to write an example of this in your notebook, and then you are done. If you did not already do the 6.2.1 homework, your problems are 46, 49, and 51. So make sure you guys get those done. That's all I have for you. So tomorrow we will do lesson 6.2.2.